Welcome to a CalcBC introductory lesson on infinite series. What you see in front of you is a shape, and that shape is divided into two parts. So I depict that on the left there as 1/2. And then the rest of that shape, which is on the right side, is split up into two again. So I show that piece as 1/4. So there are 4 of those pieces. 1, 2, 3, 4. And then that's split into half again, and 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 so on, and so on, and so on, an infinite number of times. One thing that we could think about is the sum of all of these fractions inside of this shape, and whether that sum would converge or diverge. There are two thoughts that I have immediately about that. One is, why would we actually do that? Is it just because we're curious? Does it actually help us with something? And the other thought I have is, well, I really want to know that sum now because I am curious. Or if somebody presented a question like this to me, I would want to try to figure it out. Well, let's hold that thought for a moment. Let's go back to the beginning, just briefly, when Isaac Newton and Gottfried Leibniz basically invented calculus. They created a mathematic discipline. Well, after Newton and Leibniz, there was still mystery about infinite sums and division of infinitesimals. Newton died in 1727, by the way. And that word infinitesimals, I think of it as more related to the work of Gottfried Leibniz, whereas the phrase method of fluxions, or the fluxions, the small numbers, related to the work of Isaac Newton. But don't forget, those fluxions and infinitesimals, as they relate to derivatives, we're talking about dy dx as a ratio of just really small numbers. And as it relates to integrals, that thought of small numbers relates to the very small segments that we would add up to find the area under a curve. So just because we say infinite sum, it doesn't mean that we're adding just an infinite number of numbers going up to infinity. It might mean that we have a finite space and we're adding an infinite number of numbers. Okay, all right. That's all I want to say about that. Well, here I want to say this. Some notable mathematicians who cleared up some of that mystery about infinite sums and division of infinitesimals are listed here. So I wrote their first names just because, oh, maybe you know their last names. I think you know the first one. All right, let's start with Leonhard Euler. And he's known for the development of power series. Some of the work we'll be doing in this unit will kind of reflect some of the work that he did, so focusing on certain functions and finding the relationship between series and that function. So Leonhard Euler, when he was in his 20s, by that time Newton had died, so 1707 was when he was born. The next one, Laplace. He was a French scholar, known for his work in the stability of the solar system. Oh, what's that? He was born after Euler, so Euler 1707, Laplace 1749. Carl Friedrich Gauss. Oh, I hope you knew that one. He was born in 1777 and known for the use of infinite series for derivations. And the last one is Augustin Louis Cauchy. Cauchy. I think that's how it's pronounced. Sometimes in French that last letter is silent, but this one is pronounced Cauchy. And he was born in 1789, so these are all in the order of basically chronological. And he was known for his theory of series and convergence. All right, so I share these with you not so that I can, test you on these people or anything like that, but just so that you can see how the development of this particular unit came about, by a variety of different people who we're not necessarily too familiar with. So these are some notable mathematicians who cleared up that mystery of infinite sums. Now, this page is just focused on the contributors to the study of infinite sums specifically. And just like that 3-year-old who was screaming in the background, all these guys were 3-year-olds at some point as well. And they're also listed in order in which they were born, not necessarily their deaths. So the first one, Mercator, which I think is how it's pronounced. I've always wondered if it's Mercator or Mercator. He's known for his Mercator series. And that's the one that represents natural log of 1 plus x. Euler would be so proud. So we'll take a look at that one. James Gregory, he's known for the discovery of the Taylor series. We'll be studying that in depth, and that's a major concept in infinite series. Then notice that Brooke Taylor, hey, that's the name that's listed here. Known for his work in Taylor series. You know, usually something is introduced in mathematics or science and then it's made a little bit more famous or aware in the community by someone who comes later on and writes a paper about it or something like that. And then finally, Colin Maclaurin, known for the Maclaurin series, which is basically connected to the Taylor series a lot, which you'll find out. And I've always wondered, I'm like, why does this Maclaurin sound so familiar even before I studied calculus? And it's because the McLaren car, Formula One, oh my gosh, okay. So not that for our studies, but that's one way you could think about or memorize it or something if you like Formula One. Okay, those are the four men. They provided some big contributions to infinite sums and series, but they were puzzled and intrigued by the patterns in the sums of numbers. And we will be too. But let's take a look at a few to get us going. I have three sums for you to consider, and basically the question is whether they add up to 0, 1, or infinity. And the first one really takes us back to the picture that was presented to you in the beginning. What is the sum of 1/2 plus 1/4 plus 1/8 plus 1/16 forever and ever? Keep having that number, that fraction, and see what that sum becomes. Well, here's the visual for you. How many squares do you see? How many shapes? And that's basically how I think about it, because the sum of that is simply 1 square. That one in particular we'll learn pretty quickly about how to find that sum because it's a geometric series. Here's another one. Does this add up to 1? Sorry, 0, 1, or infinity? Basically 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5. The denominator is increasing by 1, but the numerator is staying 1. Is it 0, 1, or infinity? Now I ask those ones because those are the most special numbers in mathematics. It's infinity. Last one. How about this alternating series? 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. What do you think the sum of that is? Well, it's 0, right? Wait. No. It's 1. Yeah? Oh, shoot. It could be neither. No? Are you puzzled? Intrigued? I am. I'm also enamored by a mathematician like Leonhard Euler. You know, he noticed the patterns in infinite series and proved the power series expansion for E and the inverse tangent function, all while he was losing sight in one of his eyes. So if he can notice patterns, you can notice patterns. You can rock out this unit by using your intuition. I really think this is a unit that you can enjoy the ride as well, but be sure to collect supplies on your way to survive. Okay, well that's all I have to say. Thanks so much for checking out this introductory video. Your next step would be to just work through the lessons, taking notes on the videos, doing some practice, and asking good questions. Thanks. Enjoy the ride.